Alright, so on to lesson 9.2. Remember that a pointer contains a value, which is a memory address. Every pointer is designed to contain a memory address, and a memory address is just a number and a binary sequence, no different than any other number. A pointer has no real meaning except for the memory address it contains and what is located at that memory address. So if our pointer contains the memory address of, let's just say, 8 in binary, then it has no meaning except for the memory address 8 and the data that resides at that memory address. So let's take a look again at our 16-byte RAM example. Now, remember that since we are talking about a string of text, we are talking about the data type char, which is of course short for character, which refers to single bytes of ASCII encoded text. Remember that char is always 1 byte in size. ASCII characters are always stored in a single byte of RAM. Notice that we have reverted back to the state of RAM before we changed the A to a B like we did in the last example. Everything is reverted back to the way it was when we started. Now, in this example, we still have a pointer named PTR, and this pointer PTR still contains the memory address 8 in binary, which corresponds to the start of the string, which is of course the A character. Now, we know from the previous example that you can change the data at this location with the following line of code, like so. And this would effectively go here and change this to a B, like so. What if we wanted to change the next character? So, what if we wanted to change this character? How do we do that? In general, if you want to look at or change any data in memory, you only need to know the memory address of the data that you want to change. It turns out we already know the memory address of the next character. It's simply going to be 8 plus 1, which is 9, which in binary would look like this. In other words, if we just add 1 to the memory address, let's revert back here to make this the way it used to look. Okay, here we are. This is the way we started. In other words, if we just add 1 to the memory address of the A character, we will have the memory address of the next character, which is in this case the B. If we add 1 to that address, we get the memory address for the C. If we add 1 to that, we get the memory address of the 1, and so on. If we want to change the lowercase a in our RAM, we simply set a pointer called PTR, for example, to that memory address, which is in this case 8, and we set star PTR to a new value, for example, like so. And then, of course, this line of code will have the effect of locating this position of memory and changing what is at that location so that it becomes a B, like so. If we want to change the next character, then we would set PTR to point at the memory address 9, which is right here, and then we would once again be able to, once we've set it to that memory address, we can once again write star PTR equals, let's say, C, and now because it's pointing to that memory address, it will directly manipulate it and change it into a C, like so. So now let me show you that in action. Let's first of all revert this back to the way it was when we started. So this is of course going to be... Okay, so here we go. So again, we are imagining that this RAM exists just like this when we start our program, and that PTR starts out being set to the value of 8, which is where the string of text begins. So if I start by writing this line of code, then with this instruction I've changed the lowercase a to a capital A. Which of course means that this is also going to become a 0, because if you remember, this third bit is basically a flag that indicates lowercase or capital in the case of letters. Now if I write PTR equals PTR plus 1, remember PTR is the memory address, not what is at the memory address, but the memory address. So here what I'm saying is I'm changing PTR, which is a pointer which contains a memory address. A memory address is just a number. I'm saying make that 1 higher. So now PTR will no longer be pointing at 8, it will be pointing at 9. And now if after writing that I write this, now I've changed where PTR points by adding 1 to it. And now that it points to this location, if I manipulate it like so, I have just changed the lowercase b to a capital B. I can do it again. I can write PTR equals PTR plus 1, and then I can write star PTR equals C. And with these 2 lines of code, what I am doing is, first of all, by adding 1 to PTR, I'm making it now point at the memory address, not 8, not 9, but 10, because I've added 2. And then by changing it to a capital C, I have manipulated it like so. So what are we saying here? First of all, the pointer PTR is pointing at the memory address 8, which is the lowercase a in our 16-byte memory. By executing the instruction star PTR equals capital A, we have changed the lowercase a into a capital A. Then we added 1 to our pointer. Now instead of the pointer looking at position 8, where the lowercase a was, it is now looking at position 9, where the lowercase b is. Then we changed the lowercase b to a capital B, and finally we changed the lowercase c to a capital C. When we are all done with that, we are left with this situation. PTR contains the memory address that it last had. Notice that PTR is pointing where we left it, at the memory address 10, because we changed PTR, added 1 to it, and then changed PTR and added 1 to it again. Now in this example, we have changed the data that used to be lowercase ABC, and we have changed it so that it became capital ABC. Also, you have seen an important principle in action. It is often necessary when working with data to start at the beginning of the data, do some processing, and then continue through the rest of the data, each time incrementing your pointer so that it points to the next data we want to manipulate. For example, if you had, let's say, a music file that you wanted to play, you would point the pointer to the start of the music file, do some processing, which in this case would in some way relate to playing that music, and then you would move your pointer and so on. That's a simplified example, but I want you to understand the concept. You set the pointer to the start of the data, and then you do whatever actions you're going to do on that data, and then you increment the pointer, do the data again, increment the pointer again, and you keep doing that until you have gone through all of the data. You've also learned an important fact concerning pointers. You can add a value to a pointer and cause it to point to a different location in memory. For example, we started at the memory address 8. Then we added 1 to the pointer, and now that pointer contained the memory address 9, and then 10, and so on. Whenever you change the memory address of a pointer, you are also changing what data the pointer sees. In other words, if a pointer called PTR contains the memory address 8, then star PTR would refer to what is at the memory address 8. If you change the value of that pointer and make it contain the memory address 10, then star PTR will now contain what is at the memory address for 10. If we change the pointer so that it points to a different memory address, then star pointer, or what is at that memory address, takes on a new meaning. Anytime you change the memory address contained in a pointer, then you are changing the meaning of what is at the address of that pointer. So just one more time, whenever you change the memory address of a pointer, you have changed what it is looking at. Therefore, the meaning of what is at that memory address will be different.